Okay, in this first video on optimization, what I want to do is have a look at Vector3 magnitude and Vector3 square magnitude. So these are two properties that are available on the Vector3 class, or I'm using Vector2 here. And one of them returns the absolute magnitude in unity units of the vector, and the other returns the squared magnitude. So why is this important? Well, in magnitude, what it's going to do is it calculates the square root magnitude, and then it square roots it, and square rooting is a fairly expensive operation. And generally this isn't going to be a big problem, but in the case of a Unity application where we might be doing this in update, we might be doing this thousands of times a second, and what that can result in is actual considerable amounts of frame time spent just square rooting this so that we have it in an actual like Unity units distance rather than the squared distance. So I've got this example here. It's a really basic script. It's got two on-GUI buttons that run each method, and then it's got this loop using magnitude and loop using square magnitude. And what I'm doing here is I'm starting a system diagnostics timer. I'm then looping through and the only thing I'm doing in this loop is getting the value of Vector2.1 magnitude. We're isolating out just the magnitude and the square magnitude here, because Vector2.1, I've just gone and checked, actually returns a static read-only. So this is created when the app starts, and then it just returns a reference to this. So we're not doing any sort of newing or garbage collection or anything else that's going to really make any meaningful difference. So then we do that, we basically just go and see if it's greater than 1 X number of times, stop the timer, and then debug an output message. And then the loop using square magnitude does exactly the same, except it uses square magnitude. And I'm going to click each button. So if we loop using magnitude, this is going to be doing the square root calculation, 495 milliseconds. If we do exactly the same without using the square root operation, we've got 335 milliseconds. So yeah, we've saved probably 160 milliseconds on not doing the square root operation. So if we go back into the code, there's just one thing else I want to mention is right here. I'm just comparing this to 1, right? Say we want to do this to within, say, 10 units, right? Here, if we do this, this is no longer correct because we're actually comparing it to the square magnitude. So it's going to be magnitude times the magnitude. So what we want to do is, before doing this this greater than test, we need to calculate the square of what we want to test against. So what I'm going to do here is float is, say, 10 times 10. And then we can pass this in here. So what we've done is we've done the squaring operation outside of the loop. That is going to save us some time, not a huge amount, but we only ever need to calculate this once in this example. So what I've done is I've calculated 10 squared outside of the loop, so this gets calculated once when the function runs rather than every single time. And yeah, and then we're checking that. So we're checking the square of the magnitude against the square of what we want to test it against. Thank you very much for listening. I'm going to try and get some more of these sort of tips and tricks videos out. I've got probably about 4 or 5 different topics I can think of covering straight up, but if anyone wants me to cover anything, please let me know. Cheers guys, bye, have a good day.